Hi, Sally Walker here, your hormone and slow age expert. So let's have a little look at this ATP production and see if I can give you an overview of a relatively, or maybe the word is very complex, production. I remember having to learn this when I studied physiotherapy, and I never really did understand it, I think, at the end of the day. But I've been trying to teach myself this again. So let's see if I can explain it to you, really. So at the end of the day, it's the start of this production of ATP is all about making a molecule called acetyl CoA. And acetyl CoA can be made from the breakdown of glucose, and that has a specific name. It's called glycolysis, and that happens in the cell fluid, so the cytoplasm as we call it. And we can actually make a couple of molecules of ATP there without oxygen. So we always can turn our glucose into ATP without the oxygen. But if you want to get the biggest bang for your bucks, then you want to get that glucose to be acetyl CoA and get it into the next part of the energy production called Krebs cycle. So anyway, so we can do this with glucose, can make acetyl CoA. We can also do it with fats. So fatty acids will go through something called beta oxidation, and they will make acetyl CoA. And we can even do it a little bit with proteins as well, amino acids. But we can do more with amino acids a little bit later. Okay, so once you got your acetyl CoA and you got it into the mitochondria, then the biggest part of the energy production starts on its way, and it's something called this Krebs cycle to start with. Now, the purpose of this Krebs cycle really is to make electrons, because we need that in the biggest part of this energy production called electron chain transfer. So that's what we're doing in the Krebs cycle, and we're doing this with the acetyl CoA, but we can also do this from amino acids directly coming into the Krebs cycle. But once you've got all these electrons, which are a lot of them are put onto the special forms of vitamin B3 and vitamin B2, then we go to the electron transfer chain with these electrons. And so this is the exciting bit, because this is where we really produce lots of ATP. So what happens here is that the electrons go through different complexes, as they're called, so the different protein pits, and different things happen as they go through these complexes. One of the things is that the electrons go to the one side and the protons go to the other side of the membrane. Remember I told you about these membranes, which are very, very important. So the ions coming from the Krebs cycle are divided into electrons and protons, because that's what they do. Atoms have neutrons and electrons and protons, don't they? Yes. So the electrons go to the one side and they're negative, and the protons go to the other side of the membrane and they're positive. And as the protons build up, it's like blowing up a balloon. So the pressure builds up in this area on the other side of this membrane, and this pumping up of these protons and their positive energy creates a force which is big enough to, at the end of these little complexes, create ATP. That's basically what it happens. So you've got to make some acetyl CoA. But once you've got the acetyl CoA, you're going to make some ions in the Krebs cycle, and these ions are then going to go into the electron chain transport, and they are going to be divided into electrons and protons, and the protons are going to pump up this energy and make this force, which is going to actually force a phosphate onto the ADP, which makes ATP, and that makes it all technical, doesn't it? But anyway, that's basically what happens. You've got your ATP that can be stored. We can store ATP in the cells in various places, or otherwise we can use it or the cells can use it to make the energy that they need to do the work they need to do. So your muscles work, so your brain works, so your heart pumps, so you can move, etc., etc., etc. Anyway, have a look at the article, because it's all written down and you'll be able to read it several times and maybe understand it better. What is important related to the ATP production is that you have enough nutrients, and there are very specific nutrients which are necessary. Obviously, having enough glucose or having enough fatty acids or having enough amino acids, they're all fundamentally important. But also having enough of other nutrients, especially the B vitamins, they're exceptionally important for, especially for the Krebs cycle. And magnesium is actually very, very important for the breakdown of glucose in the cytoplasm. So the glycolysis, making the acetyl CoA, is very important that there's enough magnesium there. So there's lots of things. And you're thinking, well, could I test this? Yes, you absolutely can. You can do some testing to find out if your energy production is working properly. So if you've got enough fatty acids, got enough glucose, etc., if you've got enough B vitamins, if you've got enough magnesium, and all these kind of things, you can see how effective your mitochondria are working or producing energy by the byproducts in your urine. So there is a link in the articles about testing mitochondria where you could have a little look at these tests and see if it's something that you would like to find out, which I think is pretty important, isn't it? Because as I said, if your little cells are not making energy, so if your little mitochondria are not producing ATP, you are not going to feel empowered in any kind of way. Happy hormones, happy life.